DLCO tells us how efficiently oxygen moves from the lungs into the blood. The gas first reaches the alveoli, then crosses the alveolar capillary membrane and is finally taken up by RBCs to bind with hemoglobin. So any problem with any of the structures along the pathway will affect DLCO. If the alveoli are damaged, like in emphysema or ARDS, there is less surface area, so DLCO goes down. If the membrane is thickened, like in fibrosis, gases cannot cross easily. Again, DLCO goes down. Now, if someone has low hemoglobin, like in anemia, there's less capacity to bind gases, so DLCO reduces. But if there is more hemoglobin, like in polycythemia, DLCO increases. If blood flow to the lungs is blocked, like in pulmonary embolism, or decreased, like in pulmonary hypertension, DLCO drops. But if blood flow is increased, like in left to right shunt, exercise, or obesity, DLCO goes up. Now let's look at some special situations where DLCO changes. The Valsalva maneuver, which involves a forceful exhalation against a closed airway, increases intrathoracic pressure. This reduces venous return and blood flow to the lungs, leading to decreased DLCO. On the other hand, the Muller maneuver, where a person inhales forcefully against a closed airway, increases venous return and pulmonary blood flow, thereby increasing DLCO. At high altitude, DLCO increases over time due to the body making more RBCs. In asthma, the alveoli are normal, so DLCO stays normal or may even be slightly increased, but it never decreases. In the end, here is an interesting one: pulmonary alveolar hemorrhage. In this condition, red blood cells leak into the alveoli and the hemoglobin within them bind the carbon monoxide directly, causing a falsely elevated DLCO. That's it for today, but keep watching our videos because we come up with high yield questions that are frequently asked in your exams.